So the other day I was browsing around the internet looking at cool websites, looking for some inspiration maybe, when I came across this really interesting snake effect on robertcooper.me. When you hover your mouse over and through this gridded header, snakes begin to appear, grow, and travel until they hit the sides of the section, and only then do they disappear. Clearly this animation is made using HTML5 canvas, so let's open up a CodePen. Let's get rid of this white screen. This is as much CSS as we're going to need. Write a canvas tag in the HTML, and this is as much HTML as we're going to need. All of the magic here happens within the JavaScript. We declare a variable canvas to reference the canvas we just made, and then a context which allows us to draw on this canvas of ours. The first function we need to make is an animate function that we immediately fire when the page loads. We use request animation frame, which will continue firing this little block of code. It's like a set interval, but request animation frame does a good job of waiting for the previous frame to be fully rendered before rendering the next one. Performance-wise, this is what they recommend when making browser games. Right after request animation frame, we're going to put a clear rect that clears the entire canvas on every frame so the animation will actually happen. Otherwise, your screen will look like a 1990s computer virus. We're going to create a fill style of 222 to give the canvas a nice little background, which will set a stage for these snakes of ours. Now for the snakes themselves. We create a new class, let's call it snake because we are super original. As for the constructor, we're going to add X and Y for now. I'm thinking we just control the head of the snakes first and worry about the bodies later. Let's add a width and height of 8 pixels. We're going to keep everything divisible down to 1, so 1, 2, 4, 8, 16, 32, etc. This is going to be important to maintain a grid structure. Let's create a draw function that handles the drawing of our snake. Put a context fill style of white for now, and then we fill a square located at this.x and this.y with the width and height we set a second ago. But how do we figure out the x and y coordinates? Oh right, Bob did this based on where the mouse was positioned. We need an event listener attached to the canvas itself that answers to the mouse move event. This is going to call another really original function named mouse move. We can declare the x and y coordinates just like this. We're going to have multiple snakes, so let's declare an array of snakes and a snake count up top here. Back to our mouse move function, every time the mouse moves, we need to increase the snake count and use that as an index so we can identify which snake is which. We need to splice in a new snake class each time we do this. Let's add the index to the snake class constructor so we can identify it later when we want to remove the snake from the canvas. One thing before we test this, we need to add each snake to the canvas inside of the animate function. Okay, let's see what we have so far. Nice, we can draw snake heads on the canvas, but they're not moving, they don't have tails, and they're not on a grid. We can solve the grid idea by defining a grid size variable along with a put on grid function. This function will flatten any number to the nearest grid point by dividing the number you input into it by the grid size, rounding it down, and then multiplying by the grid size again to find the new coordinate. We can apply this to the x and y coordinates of the snakes, and bam, the snake heads are stuck to the grid. We can still draw on the canvas, but now the points are contained. Now let's solve the movement of the snake. Let's create a new function inside of the snake class called update. This is going to update the position of the snake heads. We're only going to render the snake head if it stays within the bounds of the canvas. So we create this little if statement that keeps the snake heads between the top and bottom, left and right of the canvas. If the snake goes outside of the canvas, we need to remove it from the snake array. This is a little bit of garbage collection that ensures the snake array doesn't just keep getting bigger. For each snake, if the index equals the snake's index that's outside of the bounds, we splice it out of the array and remove it entirely. Let's change the function inside of animate to update, then put draw inside of update. Now we can begin moving the snake heads. Bob had the snake heads move only north, east, south, or west, so let's create a switch case that defines each one of these. Let's add another variable inside of the snake class constructor called direction, or dir for short. When we create a new snake, we will give it a random direction, 1 through 4. We can do that using a quick function that spits out a random number. Now each time the snake is created, it will be assigned a random direction identifier. Let's add a new variable set under the constructor marked for speed. The snake's speed, x and y, will determine how far the snake head moves on each frame. Let's set the speed to 8 and 8 so it will always connect with the head. Then depending on which direction the snake head is told to go, we will increase or decrease the x or y coordinate. Let's take a look at what we have so far. Oh nice, the snake heads are created. They move in the direction they're assigned, and they disappear once they hit the bounds of the canvas. Perfect. Since we have the random function already made, let's assign the snake heads a random color. We'll add this.color inside of the snake class constructor with a getRand between 1 and 3. And then inside of draw, we'll add a quick switch case depending on the random number that's spit out. We'll assign the snake head something different. That was easy, and now it looks colorful. Now let's make the snake heads change their direction as they move. To do this, we're going to need to keep track of a few things. We need the frame that the snake is is currently on, let's call it count dir, and we need a maximum of how far it will go before it changes direction. We'll call it max dir. After this .draw inside of update, we're going to add a little if-else statement. If count dir is more than or equal to max dir, then we need to change their direction. Otherwise, we will just keep incrementing count dir and we'll stay moving in the same direction. Every time we reset to a new direction, we have to start at 1 instead of 0. If you restart at 0, then you won't create a perfect grid. The snake needs to continue moving, it can't go backwards, otherwise it eats itself. So if the snake is moving east, it should only be able to go south, north, or continue moving east. To accomplish this, we create a switch case that defines what direction we don't want to go. We can call it exception. Direction 1, which is north, should not be able to go south again, which is 3. We then put this into the getRand function again so we can get a random direction, except we need to add to it a little bit. We need an exception that states if a random number created does not equal e, we return the value. Otherwise, we run the function again. This makes it recursive, but it won't be long until it finds the random value we're looking for. Let's look at the progress we've made. That's awesome. As you can see, there is a perfect grid created by all of these snake heads, and they move in random directions, but never straight back to where they came from. One more task to handle here, the snake tail. To do this, we need to keep track of the previous position the snake heads were at. We'll add a this.prevPosition array into the constructor, so we can keep track of them. Along with this, we're going to add a length variable, which will define how long the snake will be. We create a for loop inside of the update function starting from the length and then down to 0. If I equals 0, then we record the first previous position as the x and y of the head itself, or the first bit in the array. If it's not, then it must be the previous x and y in the array. This extrapolates up all the way to the end of the snake. Now inside of the draw function, we add one last for loop, but let's get a little creative. Let's let the snake fade out as it moves. We set the for loop for the length of the snake and set an alpha variable dependent on the snake's length. We use the same fill style as the color that was originally assigned, but with the alpha value after it. Now we context fill rect the correct previous position index, and that should do it. And here you have it, a perfectly gridded out snake effect that reacts to mouse movement with lots of customization options in around 100 lines of code. Pretty cool effect if I do say so myself, but we have Robert to thank for this bit of inspiration. When you break down huge problems into little sections, into little bites, they become a lot easier to handle. Thank you, Bob. That was fun.